All right, so here's how we are going to create force diagrams, okay, or called free body diagrams more often in upper level physics, okay. Is first, let's look at our person. All right, so let's draw the interaction diagram. Okay, so we have the earth, the ground, okay, the person, the box, the table, and the spring scale, okay, which is what he's holding, okay? All right, so let's take a look at all of these objects that we have, all right? And again, we won't draw interaction diagrams forever, but they're really, really helpful, especially as you're learning and for conceptual questions, okay? All right, so let's see what's interacting, okay? So the table is on the ground, all right, and that's a normal interaction, like a normal push, okay? The person is on the ground, which is also normal. All right, I'm not going to say any friction here because nobody's really sliding back and forth at all. Everyone's just kind of standing, okay? The person is holding the spring scale, and I would say he's sort of pulling up on it, so I'd call that a tension. The spring scale is also sort of pulling up on the box, so that's a tension. Okay, the box is sitting on the table, right? And the table and the box are pressing against each other. That's a normal. Okay, the person's not touching the box. The box is not touching the ground, the person and the table. Okay, so I think that's it. All right, and then let's give everybody an earth. Okay, so spring scale earth, table earth, and then box earth. Okay, and I'm not really going to put ground and earth, right, because we don't really care. Okay, so when we draw the force diagram, what we want to do is we want to think about looking at each object individually. Okay, so the first thing we want to do is the box. So I'm going to draw this dotted system line around the box, all right? And I can see that there are 1, 2, 3 interactions with the box, which means there's going to be 3 forces, okay? So anytime there's this interaction, this is a force that goes both directions and acts on both objects equally, but in opposite directions, okay? So we're going to start with the box, all right? And the box is going to have the spring scale pulling up, and I might have to adjust these sizes later, right? So, okay, here, wait, actually, I don't want to do this yet. Let me go down here. Okay, so let's look at the interactions first, okay? So what did I say? Box and spring scale? Okay, so the objects are going to be box and spring scale, okay? And that is a tension force, so we're going to call that force tension, okay, with a subscript capital T. And then we're going to be feeler dealer. So in this case, the box is the feeler, okay, and the spring scale is the dealer. All right, so the feeler is the object that you're making the force diagram of. You always want to draw force or free body diagrams on the object. Okay, so we're going to label this force tension on the box from the spring scale. Okay, and the box feels it upward. All right. Okay, let's see what else is interacting with the box. So we have the box and the earth, okay, which is going to be a force of gravity, right? That's a gravitational interaction between the box and the earth on the box from the earth, because the earth is the dealer of the gravitational force, okay? So don't put gravity. We're going to learn a different thing to put in a minute, but not yet. Okay, so it's going to be force of gravity on the box from the earth, and that's a downward. Okay, and the box is also interacting with the table, and that's a normal force on the box from the table. Okay, so I have force, normal, box, table. Okay, and how is the box feeling that, right? So if the little springs in the table were kind of being crunched down by the box, those little springs would be pushing upward back on the box. So that's going to be up. Okay, so there are 3 interactions. Oops, what happened there? All right, there are 3 interactions, so there are 3 forces. I don't have any idea what this little thing is doing. Okay, there. Oh, it made a nice arrow for me. Nice. Okay. All right, so I'm going to have the box. I'm going to put the B in a circle because that's the feeler. All right. And usually in physics, we just represent it with a dot, okay, which you might kind of switch to that later, but for now, I want you to write it with the feeler in the circle, okay? Oops. That was up, right? That was up. Okay, all right. So I have 2 upward forces on the box, okay? And I'm going to put them both coming out of the box, right? Because that's how they want you to do it in AP. They want the force to be directly coming from there, okay? So one of them is going to be force tension box spring scale, and one's going to be force normal box table. Okay, those are both up. All right, and then downward is going to be the force of gravity, and I know that since this box is not moving, not changing its motion at all, it's at rest, these are going to have to be equal. So these two together are going to have to combine, okay, to make a force that's going to be equal in size to both of those. Okay, all right, so that's going to look like that. All right, now I want to do the same thing for the table. Okay, so I'm going to have table ground. Okay, and that's a normal force on the table from the ground. So FNTG. Okay, and the table's the feeler, right? So the ground pushes up on the table. Okay, of course, also the earth, which is a force of gravity on the table from the earth. All right, so that's going to be FG, table earth, and then the earth always pulls things downward. Okay, and also the box and the table are touching, right? Oops, I should have drawn this already probably, right? So if I look at the table's interaction, right, the table also has 3 interactions. All right, so table box, force normal, table box. Okay, force normal, table box. All right, and then which way is the box pushing the table? How does the table feel it? Okay, so the table's going to feel it downward. All right. So now I see 3. Now I have 2 downward forces and 1 upward force. All right, so I don't really know anything about the sizes of these. Okay, force, gravity, table, earth. Oh, actually, I want to draw that one on the other side just for ease of use. Okay, that's probably bigger than the box was, but we don't really know the mass. Oh, no, we do know 10 kilogram table, but that's okay. We don't need to worry about that yet. Force, gravity, table, earth. Okay. And then the box is also pushing down, force, normal, table, box. Okay, and then upward to balance both of these has to be the force from the ground. So that's going to have to be big enough to encompass both of these. So force, normal, table, ground. Okay, all right. Now, what I want you to notice is whenever you do this, and this happens sometimes on the AP test, not that often, right? There's going to be what we call a Newton's third law pair, which you might remember from freshman year. I don't know. Okay, so see here I have box, table, and table, box. Okay, this is like 2 sides of the same coin, right? This is the same interaction. It's just happening on either the box or the table, but those interactions are equal and opposite. So they constitute a Newton's third law pair, okay? One acts on the box, one acts on the table. So we're going to go ahead and try this new notation. We're going to put this little circle around it like this if it's a Newton's third law pair. Okay, so those have to be equal because, see, these are the same force. Okay, these are the same force interaction just from the other side. Okay, all right, so to recap, when you are drawing your force diagrams, okay, right, first thing to do is make an interaction diagram, all right? Then you don't have to obviously write this whole table every time, but you need to like dot around that and see how many interactions there are. That will tell you how many forces there should be, okay? And then for now, I want you to label it force type, feeler, dealer, all right? And then later on, we'll simplify a little bit, all right? I think that's it.